And we're on. So, you're on. So, Boyles' law, if you draw a table and you put your volume over here, it can be milliliters or liters, right? Usually in chemistry we like liters, but either works. Over pressure. So pressure is your independent and volume is your dependent. Some people put it in atmospheric pressure, but either one will work. So volume over pressure. As the volume here we go, liters. So as the volume decreases, the pressure will
go down,
increase, and vice versa, right? So the formula for Boyles' law is P1 times V1 equals P2 times V2. So the relation, we are comparing two containers. So if one goes down, the other one has to go up. Or if the other one, if this side, they have to be balanced between them. Okay. So let's get started. Underline everything that is given. 1 liter of gas. That is my, what unit is that? Liter is my volume, right? Gas at standard temperature and pressure, right? So there's my STP again. Right here. Is compressed to 473 milliliters. So that is my what? If this is my volume 1, then this is my my second volume, right? Now look, do you see how one is in liters and one is in milliliters? Spray or just take a cocktail. What is the new pressure of the gas? So I'm looking for new pressure. All right, so 1 liter. I'm just underlining what is given. 473 milliliters. And I know my STPs. Yes. All right, so let's write down the formula. Actually, we have it here already, right? Okay. So now I substitute. First of all, do you want it in liters or do you want it in milliliters?
liters.
You want it in liters. That's fine. So 473 milliliters is how many liters? That's it. Just add a 0 in front of it, right?
Wait, why do you add a 0 in front of it? Oh.
Boy, we go retarded.
Oh, I hate
Okay. So P1 times V1. I have standard temperature and pressure. If you're keeping an atmospheric pressure, the pressure is 1 atmosphere. So I set it up. My P1 standard pressure is 1 atm. That's my first pressure. It's from the standard. And then my V1 over here is 1 liter. That's pretty easy, right? 1 times 1 is 1. Is P2, that's what I don't know, so I'll leave this as P2 times V2, which is, we found out, 0.473 liters. Okay? How do I solve for P2? Yes, I divide it by this, right? I divide both sides. So you divide it by, so really this is what I need to, this is how I need to write it down, 0.47, 47. Are you with me?
Always.
All right. So this division sign I can actually, okay, so if you take out your calculator, what is my answer?
Alex. The human.
2.11. Okay. 2.11, what? If I use the atmosphere here, I'm going to have to use ATM, so atmosphere here. All right, that's it.
That's it.
What does that say? No.
2.11 atmospheres.
On top. Yeah. Zero. Up. Left.
Start below 0.473.
Yes.
Go up. Yo, I think about it.
1 ATM. 1 atmosphere.
Oh, that's it.
That's a unit.
You can use pascals or atmospheres. Okay, hold on. He has a question. I'm sorry?
Hey, but
I can't hear you. I'm sorry. All right, let's do the next one. What is given? What do I need to underline for given?
0.05.
All right, here's my liters. What else is given? This is my pressure. What else? Okay, my second pressure. And what am I looking for?
The volume of the gas.
The volume of the gas. So I set it up. What is my formula?
P1 V1 equals to P2 V2.
Right? Pretty easy, right? So my P1 is times 10 to the 6th. My volume is 0.05. Okay, I'm leaving the units out. Equals, my second pressure is 1. And I'm looking for my second volume. Right? This one is even faster. Do you need to divide by 1? Well, yes, but no, because you know it's the same answer, right? So the only thing you do is multiply. So go ahead and multiply this.
Are we just multiplying this?
Power of 6 times 0.05, and you get 200,000. Okay, so my volume is 200,000 liters. Okay, so let me show you an old way if you're still struggling with this. Let me show you a different way. If you have a hard time putting this in still, so 4.0 or 4, and then you can do times 10, and then you can do your carats right here to the power of 6 times 0.05, and you get 200,000. Okay? All right, and then don't forget, please, box in your answers. Your professors in college and in high school teachers, we don't want to chase your answers around the paper. Circle it, box it in, underline it, you know, put stars around it, whatever. But, you know, if you write a bunch of stuff down, it's kind of hard to be like, well, which one is the answer?
Oh, it's 20,000.
This is my homeboy Charles.
Okay, let's look at the next one. What is given? So, excellent. Pressure 1 is given.
Pressure, volume, and pressure.
Volume 1 is given.
3 pressures.
Ooh.
Wait, is that 3 pressure? Yeah.
Nah.
It's not 3 pressure.
Okay, so we're making diamonds now, right? We know that diamonds is graphite under pressure or charcoal under pressure. So we have,
Can it be man-made?
well, yes, synthetic diamonds are man-made. So if we took 2 liters of gas at 1 atmosphere, so that's my V1, and we compressed it. This is hold on. Okay, so this is just telling you. Maybe I should not box it in. This is just telling you that, hey, this is how you make diamonds. You put pressure on them, and now we have tools where we can put pressure on them. So I have 2 liters of gas. I have 1 atmosphere of sorry, I put down V1. It should be P1. I'm sorry. And we compressed it to a pressure of this. So this is my P2. What would the volume of the gas be? So we are actually just compressing the gas first. What is my formula? All right, pretty easy. Pressure 1 times volume 1. Pressure 1, volume 1 is pressure 2, volume 2. Okay, let's plug it in. My pressure 1 is 1 atmosphere. That's the pressure of the air in the room right now. So 1 atmosphere. What is my volume?
2.
2 liters. What is my second pressure?
6.
And I'm looking for V2, right? So how do I solve it? 1 times 2 is 2 divided by 6.0 times 10 to the 4th. Here we go. I like to put parentheses around, make it look more official. And then what do you get? Just a second. Let me just plug it in, okay? So 30,000. Okay, so actually it's very, very, very small. The volume under that much pressure would be tiny. Okay, so you can either write down, that's your V2, you can write down 0.00003 liters, or in scientific notation it would be 3 times 10 to the negative, right, because it's smaller than 1. 1, 2, 3, 4, 5. I can explain it. So if it's smaller, it has to be small because the pressure is large. It has to be small. If the pressure is large, right, pressure goes up. Remember, if the pressure goes up, what happens to the volume? It goes down, right? Or if you remember what you wrote here, if the pressure goes up, volume goes down because you're squeezing it together. Okay, last one, and then I will answer questions. Right here is the answer. So you can either write it like this, either one, right? But usually in science, we prefer the scientific notation, right? You're scientists. All right, last question here. The highest pressure ever produced in a laboratory setting was 2. So that's even smaller than when you make artificial diamonds. 2 times 10 to the 6th atmosphere. So let's see what we have. What is this right here?
That's volume.
That's my volume 1. And we have it at that pressure, so then this is my pressure one, right? Pressure, because it says at that pressure. So you do P1 V1 equals P2 V2. And then, here we go. Here's your P2. Now it's asking for the, what would the new volume be, right? So let's plug it in. My P1 is 2 times 10 to the 6th. My volume 1 is -5th, right? My pressure 2 is tiny. And then I'm looking for V2. Now, how do I solve this? Yes, sir. Yes, sir. So 2 times 10 to the 6th times 1 times 10 to the -5th divided by 0.275, and I get my V2. And let's see what that is. The hardest thing about this is putting it into your calculator. Let me make it just a little brighter. But if I make it brighter, then you can't see that, right? How about you guys plug this one in? Two times 10 to the 6th times 1 times 10th to the -5th divided by 0.275. What did you get?
72.
That's right. V2 is 72 liters. Excellent. Or 72.7 liters, right? Which is almost 73 liters. And that's how you do it. I will move my calculator. Here it is for you. Test is next week, Thursday. Tuesday, I'm taking you on a road trip. Okay, so remember, a walking trip. Okay, are we good?
Are we going to have a test on this?
Your test is on Thursday. You guys want more? Okay, let me turn this off. Would you guys like to have more?